Ever wondered how your keyboard works? How a simple press of a key results in a letter appearing on your screen? A keyboard, an everyday marvel, is an essential tool for digital interaction. It's something we often take for granted, yet it's a crucial part of our lives. Whether it's sending a quick text, typing up an important report for work, or even coding the next big software, the keyboard is our main gateway to the digital world. From the earliest typewriters to the most advanced gaming keyboards, these devices are more than just a collection of keys. They are intricate pieces of technology representing a blend of mechanical engineering, electrical engineering, and computer science. In our everyday lives, we're surrounded by keyboards. They're on our desks, in our pockets, even on our televisions. But how often do we stop to think about how they actually work? In this video, we will explore the fascinating science behind keyboards and how they work. Before we delve into the mechanics, let's take a quick journey through time and understand the history of keyboards. Our story begins in the late 19th century with the invention of the typewriter. This mechanical marvel, patented by Christopher Latham Scholes in 1868, was the first device to have a QWERTY keyboard, a layout still in use today. The QWERTY configuration was designed to prevent jamming by placing frequently used letters far apart. Fast forward to the 1930s and 40s, when teletype machines used for sending typed messages over telegraph or radio communications became the next evolution. These machines, while still mechanical, began to incorporate electrical components, setting the stage for what was to come. The 1960s brought us the computer punch card system, a step away from typewriter-style keyboards. These punch cards were a method of input for computers, where each card represented a line of code or a data record. In the 1970s, the advent of personal computers led to the development of the first computer keyboards. These were essentially electric typewriters that could interface with a computer. They were bulky and noisy, but marked a major milestone in keyboard evolution. The 80s and 90s saw the rise of membrane keyboards, which were quieter, lighter, and more reliable. They used a flexible plastic sheet printed with electrically conductive ink. When a key was pressed, it completed the circuit and sent a signal to the computer. The turn of the millennium saw the emergence of wireless and virtual keyboards. Wireless keyboards offered freedom from cables, while virtual keyboards, projected onto a surface, provided a futuristic typing experience. Today, we have a plethora of keyboard options, from mechanical gaming keyboards that offer tactile feedback, to slim and sleek chiclet keyboards, and even rollable and foldable ones for the on-the-go lifestyle. Now that we've journeyed through the past, let's delve into the fascinating mechanics that make keyboards work. When you look at a keyboard, you see a collection of keys, but there's a lot more that meets the eye. At first glance, a keyboard appears to be a simple device, but its anatomy is quite intricate. Let's delve into the various parts that make up this everyday marvel. At the heart of the keyboard, we find the keys. These are the buttons you press to input letters, numbers, symbols, or commands into your computer. There are typically between 80 and 100 keys on a standard keyboard, including the alphanumeric keys, function keys, and various control keys. Underneath these keys, there's a whole other world. Each key sits over a switch. This switch gets triggered when you press a key, sending a specific signal to your computer. The type of switch can vary from keyboard to keyboard, with some providing a tactile bump or a clicky sound when pressed. Now let's journey deeper into the keyboard. Beneath the switches is the circuit board, also known as the PCB or printed circuit board. This is the brain of the keyboard. It's a thin board made of fiberglass or a similar composite material, covered in lines of conductive material. These lines form the circuits that transmit the signals from each key press to your computer. The signals from the circuit board travel through the keyboard's cable. This is the umbilical cord of the keyboard, connecting it to your computer. It's usually a USB cable, but older models might use a PS2 connector. Finally, the housing or case encloses all these components, providing a sturdy base and protecting the inner elements from dust and damage. It also gives the keyboard its overall shape and style, from the sleek and slim to the robust and chunky. Each of these components plays a vital role in the operation of a keyboard, working together to translate your key presses into digital inputs that your computer can understand. Now that we know the components of a keyboard, let's see how they work together. So, how does a simple press of a key translate into a letter on your screen? It's all about circuits and signals. When your finger depresses a key, You're not just pushing down a piece of plastic. You're starting a journey that begins with the key switch. This is the part of the keyboard that registers your key press. It's a tiny device hidden beneath each keycap, waiting for you to press down. And when you do, it springs into action. The moment you press a key, the switch beneath it closes a circuit. This circuit is a path for electrical current, and when it's complete, a signal is generated. This signal doesn't just hang around, though. It has a job to do. It rushes off down a wire heading for the computer's processor. Now, this signal isn't just any old signal. It's special. It's unique. Each key on a keyboard has its own distinct signal, a sort of fingerprint. This is how your computer knows whether you've pressed the A key or the B key or even the ESC key. Once the signal reaches the computer's processor, it's time for interpretation. The processor, like a skilled translator at the United Nations, decodes the signal. It takes that unique signal fingerprint and matches it up with the corresponding letter, number, or function. And voila! The letter A appears on your screen, or your document saves, or your game character jumps. All from a simple press of a key. But don't forget, this entire process, from key press to screen display, happens in the blink of an eye. It's a marvel of technology, a perfect blend of mechanical and digital components working together in harmony. And there you have it, the mechanics of a keyboard, laid bare. The next time you're typing an email or playing a game, remember the journey each key press takes. From a physical action on your part, through circuits and signals, to a digital response on your screen. That's the magic of a keyboard, transforming physical action into digital interaction. Not all keyboards are created equal. There are different types, each with its unique characteristics. What are these types, you ask? Well, let's dive right in. First off, we have the mechanical keyboards. These are the heavyweights in the world of keyboards. Each key on a mechanical keyboard has its own switch underneath, which results in that satisfying click sound when you press a key. They are durable, reliable, and offer an unparalleled typing experience. Gamers and typists love them for their tactile feedback and fast response times. However, they can be a bit noisier and pricier than their counterparts. Next up, we have the membrane keyboards. These are the common types that most people use. Unlike mechanical keyboards, membrane keyboards have a single rubber or silicone layer beneath the keys. When you press a key, it pushes down on this membrane to complete a circuit and send a signal to your computer. They're quiet, affordable, and lightweight, but they don't provide the same tactile feedback as mechanical keyboards, which can be a minus for some. Last but not least, we have wireless keyboards. These keyboards take convenience to a whole new level. They communicate with your computer via Bluetooth or a wireless receiver, eliminating the need for a physical connection. This means you can use them from a distance, perfect for a living room setup or a clutter-free desk. The downside? They run on batteries, so you'll have to keep an eye on the power level. And there you have it, the three main types of keyboards: mechanical, membrane, and wireless. Each has its own set of advantages and disadvantages, and the best one for you really depends on your needs and preferences. So, the next time you're typing away, remember there's a whole world of science and history beneath your fingertips.